imagine space, we often picture astronauts floating freely, moving effortlessly as if gravity has completely disappeared. But the reality is more fascinating. Gravity is still present in space, even hundreds of kilometers above Earth. What astronauts experience is not the absence of gravity, but a condition known as microgravity. Microgravity means very small gravity. Objects in orbit, including astronauts and the International Space Station, are constantly falling toward Earth. However, they are also moving sideways at extremely high speeds. As they fall, Earth curves away beneath them. This continuous free fall creates the sensation of weightlessness. That is why astronauts float, even though Earth's gravity is still pulling on them. The human body evolved under the constant pull of Earth's gravity. Every movement we make, from standing to walking, relies on gravity. When this force is removed, the body begins to change in ways that scientists are still working to fully understand. These changes can begin within hours of entering space. One of the most noticeable effects of microgravity is muscle loss. On Earth, our muscles constantly work to keep us upright and moving. In space, those muscles are no longer needed in the same way. As a result, muscles begin to shrink, especially in the legs, back, and neck. This process is called muscle atrophy. Without proper exercise, astronauts can lose a significant amount of muscle mass in just a few weeks. Bones are affected in a similar way. On Earth, bones stay strong because they support the weight of the body. In microgravity, bones no longer carry this load. Calcium begins to leave the bones and enter the bloodstream. Over time, this causes bones to become weaker and more fragile, similar to osteoporosis. Astronauts can lose 1 to 2% of their bone density every month they spend in space.
Another major change happens to fluids inside the body. On Earth, gravity pulls blood and other fluids downward. In microgravity, fluids shift toward the upper body and head. This causes astronauts to develop puffy faces and stuffy noses. The increased pressure inside the skull can also affect the eyes, leading to vision problems that sometimes last even after returning to Earth. The heart and circulatory system also respond to microgravity. Since the heart does not have to pump blood upward against gravity, it does less work. Over time, the heart muscle can become smaller and slightly weaker. When astronauts return to Earth, they may feel dizzy or faint because their cardiovascular system needs time to readjust to gravity. Microgravity also affects the brain and balance system. On Earth, our inner ear uses gravity to help us understand which way is up or down. In space, this system becomes confused. Many astronauts experience space motion sickness during the first few days of a mission. Movements that are simple on Earth suddenly feel strange and disorienting, forcing the brain to adapt to an entirely new environment. The immune system does not remain unchanged either. Research has shown that microgravity can weaken immune responses. Some viruses that stay inactive on Earth can become active again in space. This makes astronauts more vulnerable to infections and illnesses during long missions. Sleep is another challenge. Without a regular day and night cycle, the body's internal clock can become disrupted. Astronauts may have trouble falling asleep or staying asleep. Combined with isolation, confinement, and distance from Earth, this can lead to stress and emotional strain. Mental health becomes just as important as physical health during space missions.